Namaskara, welcome back to the channel. Today we will discuss about intake air temperature sensor. As the name itself suggests, here we are measuring the temperature of the intake air. When it comes to the importance of this sensor, it helps in accurately calibrating AFR ratios. In this video, I'll explain you what is IAT sensor, why do we need IAT sensor when we already have MAP sensor and O2 sensor, what are the types of IAT sensor, and some more technical information on IAT sensor. Now let's get into the video. Now let's understand this diagram. Here you can see IAT sensor marked in red. It is present in between air filter and the throttle body in the intake air system. Here you can see ECU is getting information from IAT sensor as well as O2 sensor, and in turn by using these two information it is controlling fuel injectors and ignition coil. Now a question comes to our mind, why do we need IAT sensor in calculating fuel injector timings and spark timings? That is because by using IAT sensor we can accurately calculate AFR timings, that is our AFR table will be more accurate. This is ideal gas law. It defines the relation between the density, pressure and the temperature of air. This symbol here is called rho. It defines density in kilograms per meter cube. It is directly proportional to pressure, and as you can see here it is inversely proportional to absolute temperature, that is measured in Kelvin, and this R is gas specific constant. And this equation is important because the temperature of intake air will determine the volumetric efficiency, that is how much amount of air that is present inside the cylinder. More air in the cylinder means we can inject more fuel, which in turn means we can extract more power out of the cylinder. This is a IAT sensor. This is the housing, and inside we can see a resistor kind of an element, right? It is called thermistor. The resistance of the thermistor depends on temperature. That is, as the temperature increases or decreases, the resistance might increase or decrease. That means change in temperature will lead to change in resistance of the thermistor, and that change in resistance is fed into the ECU. And here in the ECU part you can see same wire is pulled up to 5 volts. This creates a voltage divider circuit, and that voltage is taken as an input to ECU. As the intake air flows over the thermistor, it changes the resistance of the thermistor, and that change in resistance will lead to the change in the voltage, and the ECU will get to know the temperature of air. For example, if we take an NTC sensor, that is negative coefficient temperature sensor, that means as the temperature increases, the resistance will decrease. As the resistance decreases, the voltage output of the IAT sensor also decreases. This is from V is equal to IR, that is Ohm's law. That is, from the ECU perspective, if the voltage decreases, that means there has been a decrease in temperature. That indicates the lower temperature of intake air. This is important because at different altitudes we have different air temperatures. At each situation, IAT will help accurately calibrate the AFR ratios, which help in increasing the efficiency of the engines and also reducing harmful emissions. Now let's see how many types of IAT sensors are out there. Basically we can classify them into 3 types. They are standalone IAT sensor, integrated in MAP sensor, or integrated in MAP sensor. That is, either we can have a separate IAT sensor along with MAP or MAP, or we can have IAT sensor integrated along with the MAP or MAP.
What? Bro, what are you talking about, man?
A question comes to our mind, why are integrating IAT with MAP or MAP? What is the benefits? What are the disadvantages, right? And the main reason is reducing the cost. That is, when we integrate IAT sensor with another sensor, we are reducing the number of wires. That may be reflected in the number of wires in the wiring harness because of common ground and power. Also, these two sensors will have a common connector. There will be a reduction in the cost of connector. But on the other hand, if one of the sensor fails, for example IAT sensor or a MAP fails, we need to replace the whole thing. For the standalone part, we can either replace one of the sensors. I wanted to introduce you ADC. This is analog to digital converter. This is a very important part in electronics. That is, if you go into basics, all the sensors give out analog signal. That is, a signal which is continuously varying in time scale. And then later, it is converted to a digital form. That is either 1 or 0. That is, here this is a discrete signal. This is done because a microcontroller or a microprocessor cannot understand or calculate the analog signal by default. That is, they rely on digital signals and we can only compute with the digital signals. That's why ADC will either be put inside a sensor which directly outputs a digital signal, or it can be later processed inside the ECU by having a ADC converter IC or a circuit inside the ECU. And after processing, it may be converted back to analog form depending on the actuator's input. That is done by DAC, that is digital to analog converters. Now a question comes to our mind, why integrate IAT with the map for map, right? This integration of the sensor is mainly done to reduce the cost. By integrating IAT with another sensor, we are reducing the number of wires in a wiring harness, maybe in the form of common ground or common power. Also, there will be a one connector instead of two connectors, which in turn helps in reducing the cost. But the drawback is, in case of failure of one of the sensor, in integrated type, we have to replace the whole thing. Now let's come to the symptoms. First one, we know MIL lamp comes on depending on the failure. Next, we can see a difficulty in starting up the engine. That is because ECU is struggling to calibrate AFR ratios in extreme weather conditions. We can observe a dip in engine performance. Also, this is commonly observed, increase in fuel consumption. This is because whenever the engine is struggling, the first course of action of the ECU is to increase the fuel to compensate for the lack of calibration in AFR ratios. Thus, the overall fuel consumption of the engine increases. This also increases the harmful emissions, which is not good for environment. I hope you understood my explanation on IAT sensor. If you have any doubts, please let me know in the comments. Thank you for watching. If you like the content, subscribe to the channel. I'll meet you in the next video. Bye bye.